All right, welcome. In this video, we're going to look through a couple of titration problems, and this is an application of some acid-base reactions combined with some stoichiometry. So we're going to think about our stoichiometry problem-solving process, and we've got our general steps written down off here on the left. In general, whenever you're doing a stoichiometry problem, first step is to find moles of what we call your known. That just means like whatever the thing is that you have enough information to find moles of. And there's a couple of options. If you're dealing with a solid, this is something we did a lot back in Unit 4. We took the mass divided by the molar mass to find moles. Right now, when we're dealing with these acid-base reactions, we'll find that most of the things we're dealing with are solutions. So if you have a solution, something that's aqueous, and you want to find moles, what we're going to do is we're going to take our molarity times our liters, and that will give us moles. So that's step one, find moles based on what you're given. Step two, you're going to look at your balanced chemical equation, and that gives you the coefficients. And the coefficients are basically like our recipe. They tell us the mole ratio. They tell us how many of one reactant we need to react with something else. Like in this example down here, our coefficients tells us for every 4 aluminums, we need 3 oxygens, and then we'll make 2 aluminum oxides. And we can write these mole ratios as fractions. You might remember doing this back in Unit 4. And here's a general kind of setup of how you might use a mole ratio. Of course, you can show your work in a variety of ways, but this is just one way to do it. And we'll look at examples of these in a moment. And then step 3 is going to vary based on the problem. The problem might ask you to find grams, in which case you could use your periodic table and the molar mass. If it asks you to find molarity, remember molarity is moles divided by liters, so you could do that. It could ask you to find volume, which we can rearrange molarity equation to find volume. So this last step is going to always vary based on the problem. So let's look at this problem. Problem number 1. You're given a solution of 0.1 molar HCl and are told to find the molarity of NaOH. And let's start writing down things that we know. I'm going to start by underlining them. So things that we know. We know the molarity and the volume of HCl. So we know we have 0.1 molar HCl, and we know the volume is 10.54 milliliters. I am going to translate my milliliters into liters, because if you look at our molarity equation, our volume has to be in liters. So I'm just going to do that. So that's 0.1054 liters. And then I know a volume of NaOH. So we got 13.17 milliliters of NaOH. That's 0.01317 liters. So it looks like HCl is our known in this case. HCl, we know both the molarity and the volume, whereas NaOH is our unknown. That's the thing we're trying to find. Notice the question asks us, what is the molarity? So that is our unknown. All right, so step 1, we're going to find moles of our known. So we're going to take our molarity, which is 0.1 molar, times our liters, which is 0.01054 liters, and that is going to give us our moles of HCl. And so that is just 0.001054. Be careful keeping track of those zeros. 0.054 divided by, I just want to make sure I wrote this down right. Okay, and then we're going to use the mole ratio. So this was step 1. Step 2, I'm going to use the mole ratio. I'm going to say, okay, I know it took this many moles of HCl to neutralize all of our base. If I look at my balanced chemical equation, this tells me that my acid and my base react in a 1-to-1 ratio. So it looks like for every 1 HCl is going to react with 1 NaOH. So if I have 0.001054 moles HCl, I also have that many moles of NaOH, 1-to-1 ratio. And then step 3, I got to look back at the problem. What's it asking me for? It's asking me to find molarity. So in this case, I'm going to use this equation. I'm going to take my moles, 0.001054 moles, divided by my liters of NaOH. So that's this one right here, 0.01317 liters. And then when I do that, 0.01, so I'm doing the math with you right now, 0.0317. Okay, that is 0.080 molar. So I've just figured out the molarity of my base. And the way that I did that is I figured out how much acid it took to neutralize the base. So I can figure out moles of acid. I know the ratio in which they react. Then I could figure out how many moles of base must have been in my container. All right, this is an example of a problem with a 1-to-1 mole ratio. Notice there's no coefficients written here. So we assume everything's a 1-to-1. Let's look at another example where it's not a 1-to-1 ratio. Okay, so in this example, it looks like KOH is our unknown. Okay, we don't know the molarity of it, but we do know that it takes 60 mils of 0.75 molar H3PO4, that's phosphoric acid, which is, is an ingredient in Coca-Cola. It takes this much phosphoric acid to neutralize my 150 mil sample of my base. All right, so step one, I want to find moles of my known. That is the thing that I have the most information about. Notice, like in this case, that's H3PO4. So I'm going to take my milliliters and I'm going to divide it by 1,000. So that's 0.060 liters. And to find moles, I'm going to take my molarity times my liters to find my moles. 0.75 times 0.06, and so that is 0.045 moles of my, that's my H3PO4. It's always good to label it along the way so you remember what it is you're talking about. Okay, now we're on to step two. I'm going to look at my balanced chemical equation for the mole ratio. And this equation, the mole ratio tells me that for every 3 KOHs, I react 1 H3PO4. If they react in a 1-to-3 ratio. Okay, so that's the info I'm going to use. So that means if I had 0.045 moles of H3PO4, I'm going to say, well, it takes 1 H3PO4 for every 3 KOHs. So that means that I had 3 times as much KOH. So 0.135, that's how many moles of KOH, must have been in my sample. And then the last question says, what is the concentration? So I'm going to be using, I want to find molarity. So I'm using this equation right here. So step 3, molarity is moles divided by liters. So I've got this many moles KOH. And then my volume of KOH is 150 mils. If I divide it by 1,000, always remember to divide by 1,000. That's 0.15 liters. Divided by 0.15, and I get 0.9 molar. All right, let's try one more. In this case, let's see, what do we know? We know that we have a 0.34 molar solution of HCl, but the question is how many milliliters do I need? So this is actually my unknown, is my HCl, and then my base is my calcium hydroxide. I know that I have 14.91 milliliters of it, and it's 0.265 molar. Okay, so step 1, I'm going to find moles of my known. That's this one right here. This is the one that I know. So remember, I'm going to convert my milliliters into liters. I'm going to divide by 1,000. And to find, step 1 is always find moles. And when I have a solution, the way that I find moles is molarity times liters. So I'm going to take my 0.265 molarity times 0.01491 liters, and I'm going to plug that in my calculator. Make sure you are actually practicing using your calculator and not just like watching a friend do it. Okay, 0.00395. And I suggest labeling it so you know moles of what. That's moles of calcium hydroxide. Okay. And then step 2 is always going to be use your mole ratio. So in this case, it's a 2-to-1 mole ratio. So when there's no number written, you assume that means there's a 1. So it's a 2-to-1 ratio based on my coefficients there. And so I'm just write down the number I just got, 0.00395, and that's moles of calcium hydroxide. I'm gonna look at this ratio and say, okay, for every 1 calcium hydroxide, I need 2 HCl. So notice the pattern here is that whatever unit is over here should go on the bottom of the fraction. So if I start with calcium hydroxide should go on the bottom, and the thing that I want to find, which in this case is HCl, should go on the top. And then, so it looks like I need twice as much HCl, so I'm going to double this value. I'm going to multiply it by 2, and so it's 0.0079 moles of HCl. And then the last step is, in this problem, it's not asking us for molarity. We actually already know the molarity. The question is saying, whoops, what volume do we need? So I'm actually going to rearrange my molarity equation to solve for volume. So I'm going to say, okay, 0.0079 moles of HCl, and then it's 0.34 molarity, and molarity is moles per liter. So we'll notice that moles cancel out, and our answer is going to be in liters here. So I'm going to divide it by 0.34, and I should end up with 0.023 liters. And then I'm going to multiply it. You don't have to multiply it by 1,000, but I'm going to because it's just a little easier to look at. That means 23 milliliters. So that's how much HCl you'd need to neutralize this amount of base. So notice how we're always following the same 3 steps. Step 1, find moles. And if you have a solution, you find moles by doing molarity times liters. Step 2, use the mole ratio. Step 3, that's going to vary. In these types of problems, you're often asked to find molarity, but you might be asked to find volume. Yep, and just message me if you have any questions.